Good morning everyone. Myself Dr. Devahema, Assistant Professor, SRM Institute of Science and Technology. So now I am going to present about 3D object detection for autonomous driving. So today we are going to have the discussion about introduction of 3D detection techniques and what are the 3D detection techniques available, evaluation techniques, and sensor, how we are getting the data from the different sensor, what are the deep learning models available for the 3D object detection, and challenges and future directions. Conclusion. Introduction. So, in the autonomous vehicle promise safer roads, reduced congestion, and increased mobility for all. Technologies include computer vision, sensor fusion, path planning, and control system. So we need to focus more on the 3D object detection because we need the when we drive the vehicle automatically we need to detect the object correctly. The whole object should be detected and size of the object should be detected along the size. So when we have the multiple vehicles in front of the autonomous vehicle, then we need to detect the distance between the vehicle also. So 3D object detection is very critical component for understanding the environment around the vehicle. What is first 3D object detection? It identifies and locates the object in 3D space, essential for navigation and decision making. It provides the depth information crucial for accurate distance estimation and collision avoidance. The challenges, we have several challenges including data sparsity, occlusion, and the need for the real-time performance. So next let's see what are the sensors and how the data is collected from the different sensors. So we have the LiDAR technology. So LiDAR emits laser beams and measures the time of light to create a 3D point cloud of the surroundings. Accurate depth perception, but that depth size will vary when the weather conditions varies also. So camera based 3D detection also we have. So we can have the two or more cameras to estimate the depth through the triangulation. So in the stereo vision and depth estimation techniques are most important for the 3D object detection. And similarly, we can use the radar also. So in the object detection, mainly we'll be using radars, lidars, and cameras for getting the real-time information or information about the environment very correctly. Radar uses radio waves to detect the object and measure their velocity and range. It is very robust in adverse weather but lower resolution compared to lidar and cameras. So radar provides complementary information to lidar and cameras. So next let us see what are the 3D object detection techniques. First we will get the 3D data from the either from camera or lidar or radar. Then we need to convert the data into the structured data by applying the different encoding techniques. So first we will be applying the point cloud methods to get the encoded data. Voxel based approaches, point based approaches, and some deep learning based approaches also we can use it. The voxel based approaches, it divides the point cloud into voxels and apply 3D convolutional networks. In the point based approach, it will process the point cloud directly using the point specific operations. Then in the image based method, 2D object detection followed by the depth information. Then pseudo lidar techniques also we have, which transforms the images into pseudo lidar point clouds for 3D detection. Examples: mono 3D, deep 3D box. And fusion methods also we have: early fusion method, late fusion method, and different deep learning architecture for sensor fusion we have. So that is, we can use the different kind of neural network to fuse the data from the multiple sensor. Fusion method leverages the strength of the different sensor. Next, let's say deep learning models for the 3D object detection. So 3D CNN we have for voxel based point cloud. Similarly, 2D CNN we have for the image based detection, and we can use the transfer learning method. Along with the transfer learning method, we can fine tune the parameters to increase the performance of the detection. And similarly, we can use the recurrent neural network for the temporal fusion. So incorporating temporal information from the sequential sensor data. RNN architectures for used for capturing the long range dependencies. So using RNN we can predict the future position of detected objects. And similarly we can use the transformers. So we can use the attention mechanism for 3D object detection. So it focuses the relevant features in the point cloud or image. So in the transformer based architecture for sensor fusion, it combines the features from the different sensor using transformer. Next, we can use the evaluation metrics for evaluating the performance of the detection. So precision, recall, F1 score, mean average precision, bounding box overlap metrics. So these all can be used for the evaluation purpose. And majorly for the autonomous driving, the data sets can be KITTI data set. It's a widely used data set for autonomous driving, so which will have the lidar and camera data. A NewScenes dataset which is collected from the multiple sensors including lidar, cameras, and radar. Waymo open dataset which is collected from the lidar. So, what are the challenges we have, and what are the future directions? Data sparsity, occlusion. So, this is the major challenge. And then for improving the real-time performance, we can use the optimization technique, hardware acceleration, and data structure and algorithm. Efficient data structure and algorithm also can be used for optimizing the data processing pipelines for real-time performance. And we have the sensor fusion strategies, advanced fusion techniques which combines the sensor data in more sophisticated ways. So similarly, we can model the uncertainty which represent and propagate the uncertainty in sensor measurements. Conclusion. So importance of accurate 3D detection we have discussed, and benefits we have discussed, the role of deep learning we have discussed. Thank you for your attention.